In this video, we're going to learn about more variable types. We have already learned about the int data type. This is a type where we can create a variable that can store whole numbers. They take up 4 bytes in memory, and they give us a range of negative 2 billion something to positive 2 billion something. That's the size those numbers of type int can be. We define it by using the type followed by whatever variable name we select. Remember the important part about variable names? You want them to be meaningful, to express what it is that they contain. We can give them a value. Often we want to use numbers that have decimal places. These are called real numbers or floating point numbers. One data type that can hold these type of numbers is the data type double. It can contain real numbers, which means it can have digits after the decimal place. It takes up 8 bytes in memory, and it has this range of numbers. This is 1.7 over 10 with 308 zeros after it. That's a really, really small number to a really large number, which is 1.7 followed by 308 zeros. So really small to really large. So the range on a double is very large, and that gives us a lot of flexibility to the numbers that we want to use. This is a default for the real number constant. So when we use a numeric constant that has a decimal place in it, it is considered of type double. If we want to define a variable of type double, we use the keyword double followed by a name that is meaningful, and that we have created a variable that can contain a real number. And here we've assigned this variable pressure with the value 56.782. Another type of real number is the float. It is also a real number or a floating point number. It can have digits after the decimal place. It only takes up 4 bytes in memory, and because of that reduced size, it has reduced limit of values that it can have. So there's still a really small number, 3.4 divided by 10 followed by 38 zeros, a really small number, to large numbers, 3.4 with 38 zeros after it. So again, still really small to really large, but not nearly as small or large as the double. Here I've defined 2 variables of type float by putting the keyword float followed by the word pressure and area, 2 names that I've made up, and I can give them a value. Remember in the last slide that I said numeric constants. This is a numeric constant, 342.94, by default is a double. So if I want to let the system know that I don't want that to be a double, I need to follow it by an F, indicating that I want this numeric constant to be a float. Doesn't matter whether it's an uppercase or a lowercase f, but what that does is that converts that numeric constant to a float, and then I can store it comfortably in this variable of type float. If, on the other hand, I just choose a numeric constant, 452.732, and store it in a variable of type float, it's going to produce a warning saying that the number has been truncated. Because this is a double, remember that doubles are 8 bytes big, and I try to store it in a location that is only 4 bytes big, there's a possible loss of data. Certainly, a float is big enough to hold this number, 452.732, but that doesn't matter. The system does not look at the specific number. It just knows that whenever you take a double and store it in a float location, there's possible loss of data. So it will produce a warning. So since numeric constants that have a decimal value by default are doubles, when you store them in a float location, you'll either get a warning or you need to follow it by an F to let the system know that you want that numeric constant to be converted to a float and then stored in the float variable. Another type is the char data type. This data type is used to contain a single character. So when you want to have something that is a single character, you would choose this as the data type. It takes up 1 byte in memory, and there's no mathematical conversion to binary. Every single thing that is stored in a computer is stored in binary. Well, that's easy to do with decimal numbers and even floating point numbers. We can get a conversion from those type of numbers to binary. There are mathematical ways to do that conversion. With characters, it is not so. There's not a mathematical conversion. So the way they do it is with an ASCII table, which is a table that simply says for a T, use this set of binary code. So if we go down here and we look, this is an ASCII table. And if we go down and we look and see what is the capital T, so right there, a capital T, then it says for every time you need a capital T, store this series of bits to represent that capital T. Well, that capital T, those series of bits could mathematically be converted to the decimal number 84. So your system has to know what it's working with. When it sees this series of bits, is it supposed to interpret that as a character, and it would be a capital T, or is it to convert it to a number, and it would be an 84? So that's why one of the reasons why we always put types on data, so the system can interpret it correctly. But notice here that you have lowercase letters, special characters, uppercase letters, special characters, numeric digits, and a whole bunch of non-printing characters. So that's the ASCII table that is used to look up and store the binary representation of characters. Here's an example of a variable of type char. Here I've defined it by using the keyword char that identifies the type of the variable, followed by the name of the variable that I chose, gender, comma, then another one, answer. So here I've created 2 variables of type char. I've assigned the first one, gender, with the value M. The second one, answer, with the value C. Remember how character constants are surrounded by single quotes. If you want to have a variable that can contain many characters, you can use the C++ string class. This data type is defined in the header file string. To use it, you need to #include this file by using a #include statement followed by string. Always use the using namespace standard if you want the functionality of this file to be accessible directly. Now you can define things of type string. The way you do that is you use the word string. Notice this is not a keyword, so it does not turn blue, but instead it is a data type that is defined in this header file. It is not a data type that is primitive to the C++ language. So you use the word string followed by whatever you want the variable name to be. In this case, I've named my variable name. Remember, we want it to be meaningful. And then I'm going to store an entire string. Remember, strings begin and end with double quotes. What will happen now is it will store John A. Smith in this variable called name. And it can contain, string variables can contain many characters. The last data type that we're going to talk about is the bool data type. This data type is used to contain true or false. It's 1 byte big, and you can define a variable this type by using the keyword bool followed by the name, is tall or is hot. Here I've defined 2 variables. One is tall, one is hot. And now I'm assigning the variable is tall the value true. Notice how the value true, written out in all lowercase letters, is a keyword, and it is used to identify this Boolean value of true. And I can store that in a variable of type bool. Is hot, I can store the value false in there. In a bool variable, I can store true or false in either one of these variables. Notice that although they contain the values true and false, we use those keywords to identify them. When we output them, so if I output this variable is tall, it's going to print a 1 to represent true, and it's going to print out a 0 to represent false. So we use these keywords to assign values, but really what's being stored is the numeric 1 or the numeric 0 in these bool variables. So some important things to remember about variables. Variables have a name, and the way that you define a name for a variable is it should be meaningful. The name itself should describe the contents, what's being contained in that variable. And also remember, it has to follow the rules that needs to be made up of letters, numbers, or the underscore. It can start with a letter or an underscore, and it cannot be a keyword. So following those rules, it needs to have a name. It needs to have a type, and we've learned about several types: the int, double, float, char, string, and bool data types. Variables have exactly one value. They always have exactly one value, but that value can change. So we might initialize a variable to the value 6.82, and then later in the program change that value of that variable to 28.973. At any one time it has exactly one value, but that value can change over time. And it also has a location in memory. Variables are storage locations. They live in memory, and that's where that one value is stored, is in that specific location in memory.